In this video tutorial, we will learn how we can create a Streamlit application to do object detection, instance segmentation, and pose estimation using ultralytics YOLO11. Here is a quick demo of the Streamlit application that we will be creating in this tutorial. So let me first give you a quick demo of the Streamlit application that we are building in this tutorial. So we can perform object detection, instance segmentation, and pose estimation with the help of this Streamlit application. And we will be able to perform object detection, instance segmentation, and pose estimation on images and on videos. You can upload any random image, like you can click over here from browse files, and you can upload any image from here. Okay. As you upload the image, an image will appear over here. And if you want to perform object detection, you can see over here, we have by default, the object detection is being marked over here. And then you can click on detect object. And over here, you will see an output image once the object detection is being performed. So now you can see over here, we have the output image, and you can see we are able to detect bus, person, backpack, handbags. So you can see the detection results over here, like you can see now. And over here, you can see we have the bounding box coordinates over here in the form of tensors. Okay, so we have the bounding box coordinates for each of the detected object in the form of tensors. Okay, so as you expand this, you will see all the bounding box coordinates. And here you can see over here, we are able to detect a person, backpack, handbag, person, a bus, and all the things. Okay, so currently I'm using YOLO11 nano model. And if you use large models of YOLO11, you will get definitely better results. So going ahead, you can also perform segmentation as well. So if you want to perform the segmentation on the same image, you can click on segmentation from here, and you can just go down from here and click on detect object. Okay. So now you can see over here, we are able to perform the segmentation. We are able to detect the person, backpack, and we are able to draw the mask as well. So basically in instance segmentation, we draw a mask around each of the detected object. And you can see over here, we are able to draw blue mask around each of the detected object. Okay. In the same way, you can also perform pose estimation. And if you click on pose estimation from here and going below, if you click on detect object from here, so now you can see over here, we are able to perform the pose estimation, and you can see that we have drawn the key points around each of the detected object. Like you can see over here, we are able to perform pose estimation, and we are able to draw the key points around each of the detected object. Okay, in the same way, if you want to upload some other image, you can just click on those files from here, and you can upload this image from here. Okay, and after uploading this image, if you want to perform pose estimation, I am already selected pose estimation, and you can click on detect objects. So now you can see over here, we are able to detect the object, plus we are also able to draw the key points around each of the detected object. So we have performed pose estimation. In the same way, if you want to perform segmentation, you can just click on segmentation from here, and you will be able to perform segmentation. Now you can see over here, we are able to detect the object, as well as we are able to draw a mask around each of the detected object over here. Okay, so we have seen that how we can perform object detection, instance segmentation, and pose estimation on the image. Let's go to the video part. So if you want to perform object detection, instance segmentation, and pose estimation on video, you can just select video from here as the source. And you can see this is the default video. Let's first see how we can perform object detection, instance segmentation, on pose estimation on a video. So in my video directory, I have added 2 different videos. You can add as many videos you want. So as many videos you add in your video directory, you will be able to perform object detection, instance segmentation, and pose estimation on those videos. Okay, so if I select video 1, and if I want to perform object detection, like let's click on detect object from here. And here you can see the output. We are able to detect the person over here. Okay. So like this is a wrong detection. Currently, I'm using YOLO11 nano model. And if you want to get good results, you can use high YOLO11 models, which include YOLO11 large, YOLO11 extra large. The reason I'm using a small YOLO model like YOLO11 nano is that I'm currently running the Streamlit application on my CPU, and I don't have GPU in my local machine. So YOLO 11 Nano is the fastest, but it is least accurate, while YOLO 11 Extra Large is the most accurate, but it takes more inference time. Okay, so there is a trade-off between speed and accuracy. Okay, so if you want to go with another video, like you can see over here, you can click on detect video objects, and you can see over here, we are able to detect the person, bicycle over here, and detection results look quite promising. Okay, and if you want to perform segmentation, you can click on segmentation from here and click on detect video objects. And now you can see that we are able to perform segmentation. We are able to draw a mask around each of the detected object. The person are in the blue mask, which you can clearly see over here. And if you want to perform pose estimation, you can just click on pose estimation and click on detect video objects. And now you can see that we are able to detect the objects, and we are also able to draw key points around each of the object over here. You can also adjust a confidence threshold, like if you increase the confidence threshold to 0.933, like 93%, you can see detection has, like there are no detections. And if I just reduce the confidence to 70, let's see. So now you can see that it will only detect the object that have a confidence score above 70% or 0.7. So all the objects that have confidence score above 70% will be detected. So what does confidence score means? Like the confidence score means how much the model is confident that this is a person or this is a bicycle. Okay. So if you just increase the confidence score, there will be less false positives. But if you decrease the confidence score, like make it to 25, or if you further decrease the confidence score to 10% or 0.10, you will get more detections, but there will be more false positives as well. Okay. But if you increase the uh, confidence score, there will be more accurate detection and there will be less false positives, but there will be few detections as well. Okay. So this is how our Streamlit application works, and we will be creating this Streamlit application in this tutorial. So let's get started with this. So over here, you can see that I have just created a project in PyCharm Community Edition, and I have requirements.txt file, and we have ultralytics and Streamlit package over here. So to create this application, we only require two packages. One is ultralytics and Streamlit, and to install this you can simply write pip install -r requirements.txt, and if you run this, you will be able to install these two packages. So I've already installed these packages, and you can see over here requirements already satisfied. But if you are installing these packages for the first time, this will take some time. Next, we will just create a new file like main.py file. In the step number 1, we will import all the required libraries that we require in this project. So we require the OpenCV Python package, we require the Streamlit library, to define the path of our root directory. We require the pathlib library. From there, we import path. Then we require sys library. Then to object detection using ultralytics YOLO11, we require YOLO package. So we'll report from ultralytics. We will import YOLO. And to display any image, we require image lab. Okay. So let's create an initial page layout with the help of Streamlit. So we will be now creating an initial page layout. So we'll write st.set-page-config, and the page title will be YOLO11. We can also add a page icon. Next, we will define a header for our Streamlit application. The header will be object direction, firstly 11. We can also create a sidebar. We will have our all the settings, like what task we want to perform, what will be the conference schedule, and if you want to do object detection on image or on video. So we need to create a sidebar for this. In the sidebar, we will also add a header with the name model configurations. In the sidebar, we will also give the user the option to choose whether he want to perform object detection, instance segmentation, or pose estimation. So the user will have the option to choose the model type. We are just adding radio buttons over there. Detection, segmentation, pose estimation. We will also give the user the option to select the conference threshold with the help of slider. The confidence value will be the form of float. The minimum value of confidence will be 25, the default value will be 40, and the maximum value will be 100. And we will divide it by 100 because our model takes the confidence value in the form of between 0 to 1, like 0.1 is 10%, 0.25 is 25%, 0.90 is 90%. Okay, so we got it. So let's see how our each Streamlit application looks like. So we'll write Streamlit run main.py. So this will take some time. Currently, this will take some time. Let me see if there is an error. It looks fine. Okay, so here you can see we have our Streamlit application. Like you can see over here, we have the model configurations, cost detection, segmentation, pose estimation. Okay, default value. Why we are seeing this? Okay, so the maximum value is 100 and default value is 40. I've just made this mistake. Let's see. Let me refresh this up. Okay, again, I click. Yeah. Let me refresh this up. So you can see default value is 40 and the minimum value is 25 and maximum value is 100. Okay. So let's complete this application now. First, we need to get the absolute path of the current file. Then we need to get the parent directory of the current file, which is next. We will add the root path to the system dot path if it's not already there. So I will just write if root not in this path dot append. Okay. Next, we need to get the relative path of the root directory with respect to the current working directory. Okay, so we have just got the relative path to the root directory with respect to the current working directory. That looks fine. Next, so we need to define the sources. We can pass our input in the form of image and as well as in the form of video. Or input will be in the form of image or video. So let's define a source list. So we need to define some default images that will appear if the user doesn't upload an image. What should be the default image appearing? So we'll set some image configurations over here. So first we need to create a directory by the name images over here. And inside this directory, I will add some 3 images. So this is the default detected image that will appear in our Streamlit application. This is the image 1. This is the default image as well. And this is another image which will appear in our images directory. Okay. So in the root over here, we have defined a relative path of the root directory with respect to the current working directory. And we need to define our default image over here. We can go to images directory, and over here we have image1.jpg. Then we have default detect image. Then we have detected image1 dot. Okay. Similarly, we can do for the video as well. For this, I will just create another directory by the name videos over here. And over here, I will add 2 videos. Okay. We'll first define video directory is equal to root and videos. So the name of the directory is videos. Okay. Then we will create a dictionary. Right, video1, video directory, video1 dot. Then we will write video2, video directory, video2 dot mp4. Okay. Next, we need to define model configurations where we will create a wait folder over here, and I will add my object detection, instance segmentation, and pose estimation YOLO11 models. So I will just write model configuration. So first, what I will do is I will just create a new directory by the name weights over here. And inside this, I will add, what I will do over here is we can go over here. Okay. So you can just go to YOLO11 GitHub. And if you want to download any object detection model or instance segmentation or pose estimation model, you can simply click over here and you can see that it start downloading. And if you want to download any segmentation model, you can simply click over here and it will start downloading. And if you want to download pose estimation model, you can simply click over here, it will start downloading. Okay. So I have already downloaded, so I'm not downloading again. So I'm just adding these three models over here. So you can see we have YOLO11 Nano, pose estimation model, and YOLO11 segmentation model. So I will just write root, and you just need to go to the weights directory over here. So we just need to go to model directory, and here we have the detection model as YOLO11 Nano dash PT. So write YOLO11 Nano dash PT. So in case of your custom model, you will write detection dash model, and here you will write model dash directory, and over here you will add custom model weight dot pt, and you will just comment this line of code, okay, and uncomment this. Okay. Next, we need to define the segmentation model. Next, we need to also define the pose estimation model. Okay, so that things work. So we are good for now. Next, if the user, we need to add the code if the user select the detection segmentation or the pose estimation model. So if the model type is, okay, so if the model type is detection, model path is equal to path detection model, as if If the model type is segmentation, model path, path, segmentation model, L if model type is equal to overestimation, model path is equal to path overestimation model. So next we'll load the YOLO model. So when I try YOLO model path and write accept exception as st error, we can simply write unable to load model check specified path. Okay. Simply write this over here. And we can also display the error in our Streamlit application. Now we can just set image and video configurations. We'll give the user the option to select if you want to perform object detection, instance segmentation, and pose estimation on image or on a video. So we'll give the user the option. We can write st.sidebar.radio. Select source list. So we initialize source image is equal to none. So if the user selects an image, so we'll ask the user to upload an image. And the Streamlit application will accept the image of type JPG, PNG, JPEG, BMP. So I only know all these image types. If you know some other, you can also add it over here as well. Next, we will create two columns, which will contain a default image and other will contain the detected image. Or one will contain the image that the user has uploaded, and other is our output image with the detections. So first we'll go towards the column 1. So if the source image is none, like the user doesn't upload any image, then we'll find a default image path over here. And we will say this is our default image. You can also open this image. And we can also display this image in our Streamlit application using st.image, right default image path. Caption will be default image. Else, if the user uploads an image and source image is not on, then we will display the uploaded image. So if the user uploads an image, then we will display the source image. Caption will be uploaded image. Okay. And I will add accept as well. Accept exception as a. Okay. So what will be hanging? Okay. Error occurred while opening the, and we will display the error as. Now we'll create another column as well. So if source image is not, then we'll define default detected image path over here. Okay. And here we'll pass the default detected image path. Caption will be detected image. Else if the source image is there, and user also press a sidebar button, which is detect objects, then we will use model.predict it, and here we'll pass the uploaded image, and we'll pass the uploaded image over here. Then but we also define the confidence value. Concern. Let's plot the result as well. And we'll also show the bounding box coordinates there as well, right, with sa.expander. And we will display the error. And we can also add exception over here as well. Occurred while. Okay, that works. Now let's test how our Streamlit application works on image. And if it works fine, then we'll go ahead with the video as well. Okay, so let's test our Streamlit application. So here you can see that this is a Streamlit application that we have created so far. So first, let's do the detection. I will just upload this image. And if I click on detect object from here, so this is the uploaded image. Okay, so now you can see over here, we are able to detect the person, bus, backpack, and here you can see we have the bounding box coordinates for each of the detected object in the form of tensor. We can also do segmentation, and let's click on detect object from here. So now you can see that we are able to perform instance segmentation, and we have drawn mask around each of the detected object. We can also perform pose estimation, and let's click on detect object from here. So now you can see we are able to perform pose estimation, and we have drawn key points around each of the detected object. And here you can see we have the bounding box coordinates appearing over here for each of the detected object. Okay, so we are done with the image part. Let's go ahead and move towards the video part as well. Okay. So we can write and if source video is equal to video. So we write source video is equal to st dot sidebar or select box use the video radio dictionary dot keys, and we write with open video dictionary what source video. So we read it. That's type. So we need to convert the video into bytes so we can perform object detection on the video. So st.video will display the video into our Streamlit application. So if the user click on this button, that video, thanks. Then we'll add a try and accept permission. Okay. So we'll create an empty frame from now. Now we'll just create a while loop over here. And if we are able to read the frame, then we'll just resize the frame over here. Next, we'll predict the objects in the image using YOLO11. Right result is equal to model.predict. Image is equal to confidence is equal to confidence value. Next, we'll plot the detected objects on the video frame. We already have created an empty frame. We will be plotting our detected objects on that frame. And if the video frames end, then we'll release all the frames and we'll break the while loop. We can also add an except condition over here. Error loading video. Okay. So, and we will display the error over here as well. So now we have created our Streamlit application. Now it's that time to test our Streamlit application. So we can simply write over here Streamlit run mail.py. Okay. So let's test our Streamlit application. And let's see if we are able to do detection on image and video as well. We have tested for image already. Now we'll mainly test on video now. So first of all, I will just click on video from here, and I can just go with video too, and click on detect video objects from here. And now you can see over here, we are able to detect the person, bicycle from here, and the detection results look quite promising. If you want to perform segmentation, you can select segmentation from here. You can select any video that you have saved in the video directory, and then you will run detect video objects. Now you can see that we are able to perform instance segmentation. We are able to detect traffic lights, bicycle, person, and you can see over here, we have drawn a mask around each of the detected object. So this is what we do in instance segmentation. In instance segmentation, we draw a mask around each of the detected object. Similarly, we can perform pose estimation and click on detect video objects from here. So now you can see we have performed pose estimation and we have drawn key points around each of the detected object. Similarly, you can adjust the confidence threshold to 79 as well. And you can see now, as I increase the confidence threshold, the detection has decreased, but now the detections are more accurate. And if I decrease the confidence score, there can be some false positives as well, but there will be more number of detections. Similarly, you can do it for image as well. We have already tried on images and detect objects. And let me see if I have some other image over here as well. Let's use this image. And let's click on detect objects. So now you can see over here, we are able to detect the objects, and we are also able to draw the key points around each of the detected object because we have selected pose estimation. And if I just select segmentation, you can see we are able to draw mask around each of the detected objects. So now you can see over here, with the help of instant segmentation, we are able to draw mask around each of the detected object. And if I click on detection from here and click on detect object, from here, you can see that I'm able to detect different objects like person, bus, and over here, if I just expand this, I have all the bounding box coordinate information in the form of tensors over here. So that's all from this tutorial. In this tutorial, we have learned how we can create a Streamlit application to do object detection, instant segmentation, and pose estimation with the help of ultralytics, YOLO11 or images, as well as on videos. That's all from this video. Thank you for watching.